So hello and good morning to everyone. So our today's lead code question is 154, which is find minimum in rotated sorted array, and this is part 2. Like part 1 we have solved yesterday, right? So in this question we are given that we have an array having length n, and that is suppose in sorted ascending order, and it can be rotated between 1 to n times. So an example is given that suppose this is array 0 1 4 4 5 6 7. So after one rotation it will become 7 will come to the first, then 7 0 1 4 4 5 6. So after one rotation the array will look like this. So if we do three more rotation, then 4 5 6 4 5 6 4 5 6 will come here, and then the array will look like this. So this is like after total 4 rotations. After total 4 rotations the array will look like 4 5 6 7 0 1 4, right? So rotating an array in one time results in the array, like if we rotate one time, then the last element will come to the beginning of the array or the starting of the array. And so we are given a sorted rotated array, nums, which now in yesterday's question there was no duplicate, but in today's question the array can contain duplicates, right? So we have to, what we have to do is we have to return the minimum element of this array nums, right? This is what we have to do. And it is given that we must decrease the overall operation steps as much as possible, right? So we have to minimize the total number of operations that we take to find the minimum of the array. So let's see the examples. So here in this example we are given the nums arrays 1 3 5. So we take two pointers, left and right pointer. Left pointer will be pointing here, right pointer will be pointing here. Then we find the mid element. Then the here mid element is 3, and we take the right element, that is 5. Now we compare mid and right element. So here mid element is lesser than right element, mid element is lesser than right element. So that means our right portion of the array is sorted. Right portion of array is sorted. That means the minimum will be on the left side. Minimum will be on the left side, right? So what we do is we make right is equal to mid. So this right pointer will be updated and start pointing at mid. And then again we do the same thing. We take the mid element. So now our mid is equal to, mid element will be 1, and again we compare mid and right element. Now mid is 1, right is 3. Again the same condition, mid is less than right element. So we again update right is equal to, mid. So now our right will be pointing this element. So now our left and right is pointing at the same element, so that is our answer. So our answer is 1, right? So let's move to the constraints part. So here n is equal to nums dot length. So n can be up to 5000, that is 5 into 10 k power 3, and each element of the array can be from minus 5000 to 5000. And it is given that nums array is sorted and rotated between 1 to n times, right? So in yesterday's question, which is 153, that is find minimum in rotated sorted array, the difference between today's question and yesterday's question is that in yesterday's question we were given that we do not have any duplicates, right? But in today's question we can have duplicates. So first we will see how we handle the yesterday's question, right? And then we will see how we'll be doing the today's question. So in yesterday's question we have taken two cases by comparing mid and the right element. So first case, if mid element is greater than right element, let's say an example 4 5 6 7 0 1 2 3 and 4, right? So this is the mid element, and this is the right element. Now if you see 7 is greater than, let's say this array to be up to here. So 7 is greater than 3. So the first case, mid element is greater than the right element. So if we see this part, right part of the array, this part, right part of the array is fully sorted, right? It's sorted properly, and even the minimum will be lying on the right part. Minimum will be lying on the right part, which is 0. So what we'll do is we'll update our left. We'll update our left is equal to mid plus 1. So this is case 1 when mid element is greater than the right element. So this is case 1. In this case our minimum will be on the right side, our minimum will be on the right side, and so we update our left is equal to mid plus 1. Now the second case, if mid element is less than right element, mid element, let's say 5 6 0 1 2 3 and 4, right? So this is our case 2, that is, and here if this is our mid element is 1, right element is 4, and 1 is lesser than 4, so our mid element is less than right element. In that case the our minimum element is either at the mid part or on the left part, or will be on the left part. So minimum can be either at the mid or on the left part. So we are not sure that whether it will be on the mid or on the left part, so we update our right is equal to mid only, not mid minus 1, not mid minus 1, because our minimum can be at the mid also, right? So we have updated right is equal to mid. But yesterday there was no duplicates, in the yesterday question. So mid element cannot be equal to the right element in yesterday's problem. But in today's problem we have mid also, right? We have duplicates also. So this condition, that is mid element can be equal to right element, this condition can also exist today. But in this condition that mid element is equal to right element, we cannot determine whether our minimum will be on the left side or on the right side, right? We can't be determining due to due to the duplicates. We cannot determine whether our minimum will be on right side or our minimum will be on the left side if this condition exists, that is mid element is equal to right element. So let's see with the help of an example. So here mid is equal to 3, this is the mid element, this is the right element, and now both mid and right are equal. So neither case 1 follows nor case 2 follows. So we cannot determine either we have to go on left side or we have to go on right side, right? We are unable to determine. So what we'll do is so what we'll do so how will we handle this case? So what we'll do is, when we get the condition that mid element and right element are equal, when we get this condition, so in the question we are asked to reduce overall steps to solve the problem. So what we'll do is we reduce our search space. So we reduce our search space by reducing our right pointer, until this condition satisfies. So until this condition satisfies, we keep reducing our right pointer, and when we stop when we get the other two cases, right? And even after removing the right pointer, we know our minimum will still remain in the search space, because we are shifting the right pointer. Still our minimum will be somewhere between the two elements, right? So either somewhere between the two elements or on the left side, right? So let's solve this example. So first, mid is equal to 3, right is equal to 6. Mid is equal to 3, right is equal to 6, and nums of mid is equal to 2, nums of right is equal to 2, and both are equal. So in the case of equal, we do right minus minus. So we shift our right pointer by 1. So now our right pointer is equal to 5, left is equal to 0, and mid is equal to 2. Means our right pointer is here, left pointer is here, and this will be our mid. So now our nums of mid is equal to 2, and nums of right is equal to 1, and see, 2 nums of mid is greater than nums of right. Nums of mid is greater than nums of right. So this is case 1. So our minimum will lie on the right side. Minimum will lie on the right side. So what we do is we update our left is equal to mid plus 1. We update our left is equal to mid plus 1, which is 2 plus 1, that is 3. So now our left is equal to 3. Left is equal to 3. Our right is equal to still 5. Our right is still pointing to 5, and our mid is equal to 4, and this is our midpoint. Now again we compare mid and right. So now our mid element, which is 0, is lesser than the right element. Mid is lesser than right element, which is case 2. Which is case 2. In case 2, what we were doing is we were updating right with mid, because our minimum element is either on the left side or present at the mid element. So we update right is equal to mid, right? So now in our search space we are left with only two elements, that is 2 and 0. 2 and 0. So our left is equal to 3, right is equal to 4. So if we find the mid, we get mid is equal to 3. So at mid we have 2, and at mid we have 2, and at right we have 0. So again when we compare, our mid is greater than right. So again case 1, that means our minimum will lie on the right side. So we update our left is equal to mid plus 1, that is 4. Now our left is equal to 4 and right is equal to 4. So we are left with only one element. So that element will be the minimum element. So our answer is nums of 4, which is 0. So 0 is the minimum element in the array. So let's see the code part. So in the code we have taken two pointers. Left pointer initially at 0, right pointer at nums dot size minus 1, and it is in C++1. So nums dot size will also work over here. And while left is lesser than right, while left pointer is lesser than right pointer, we first find the mid pointer and then we'll see the conditions. So when mid element is lesser than right element, that means our minimum is either at mid or on left side. So we update our right is equal to mid. We update our right is equal to mid. So we have updated right is equal to mid. Then the case 2, that mid element is greater than right. Mid element is greater than right. So in that case we know our minimum will be on the right side. Our minimum will be on the right side. So we update our left is equal to mid plus 1. Left is equal to mid plus 1. Now the third case, which is having a duplicate, that is both mid and right. Mid element and right element are equal. Both are equal. In that case we reduce the search space by shifting right pointer by 1, because we don't know where in which side we have to go. Either we have to go in left side or right side, so we don't know that. So we just reduce the right pointer and then again check the case number 1 and case number 2, and after solving we return nums of left pointer. That is our answer. So I hope I am able to so explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.